Hello, everyone, and welcome to our meeting. In this presentation, I want us to have a look at embedded systems design using Arduino microcontroller. My name is Linus Alone. Arduino is one of the most widely used microcontrollers, especially in development of embedded systems. Basically, embedded systems are those systems in which there is a tight coupling between the software and the hardware. And of course, the software and the hardware are designed or customized to perform specific functions. So this will be a series of presentations building towards enabling us to program Arduino microcontroller for purposes of implementing practical embedded systems. I would want us to acquaint ourselves with different functions that can be used to write Arduino-based programs. And then in the later presentations, we will be looking at how we can design simple embedded systems by deploying the Arduino microcontroller. There are, of course, different types of embedded systems development environment, but one of the widely used environments and one which is user-friendly is the Arduino. This is because Arduino uses a programming language that is very much familiar, that is widely used. Of course, the language is basically more or less similar to the C++ programming language. When a code is written using Arduino Ide, that is Arduino Integrated Development Environment, we basically call it a sketch. We usually call it a sketch. And in many cases, the code will be written by using the Arduino Ide as software. So once the code has been written, it has been tested, and it is free from errors, then it can be uploaded to a particular Arduino microcontroller. And then now, provided that the whole system is well assembled and the hardware components, including sensors, actuators, and other devices are put into place, then now the system can be run automatically by the microcontroller. There are different categories under which we can classify the basic Arduino-based functions. There are those functions which we use to read analog inputs. We can also use them to read or write digital inputs and outputs. And basically, you realize that these functions are important in bringing the data into the Arduino microcontroller environment, or sending out processed information from the Arduino microcontroller to other components connected to the output pins. So for the digital pins, we can configure to use them as input or output, especially those which do not support PWM, but for the analog pins, we can only employ them as input pins. The other category of functions are those which are required to handle interrupt features and facilities. We call them interrupt functions. They are those which are required to implement mathematical expressions. We call them mathematical functions. And then there are those which are required to support serial communication between the microcontroller and the components connected there or connected to it. We call them serial communication functions. Arduino microcontroller also has got the advantage that within the Arduino Ide itself, it is rich in sample problems or examples. We call them built-in examples. So we can usually access the built-in examples to try and acquaint ourselves or familiarize ourselves on how to work with certain Arduino commands, like maybe if we want to read data from a particular sensor, if already there is maybe an example within the Arduino Ide library, it is always advisable maybe to go through those examples. We see maybe how we can maybe operate with some of those devices, some of those commands, and then we can always extend them to our projects. For example, those examples are categorized under, there are some which occur under sketch, bare minimum. There are some which occur under digital categories, some occur under analog, input, output, and so on and so forth, okay? So if maybe you have a new sensor that you're interacting with for the first time, you can always refer to those examples. And then now from those examples, then you can maybe see how those sensors are interfaced to the microcontroller. If you need additional information on how to use Arduino programming language, then you can refer to this link given here. That is from the Arduino website. You can refer to the Arduino language reference page, which is available at that website. Then we come to the two main sections, which usually make up an Arduino-based program. So Arduino-based program usually has got two parts or two functions or two sections, which of course are usually enclosed in the symbols for enclosing blocks of statements. The first section is the void setup section. And for the void setup section, whatever we put there will only be executed once, okay? Whatever we put there will only be executed once. For example, we can put the pin mode configurations. We can, that is where we use the pin mode function to specify if we want to use the pin as an input pin or output pin. You can also, under the void setup section, capture the serial communication speed and have the serial communication speed. Those are examples of the functions or commands which can be put under the void setup section. And of course, maybe if you're using the analog input pin, and sometimes also under the setup part, you can also specify the analog reference voltage that you'll be working with. Then the second part, which is the void loop part, and at that part is considered to be the main part of the code or the body of the code, and that is the section that will be run repeatedly. I remember that this is basically where the problem is supposed to be solved, depending on the applications at hand. So we can capture that under the void loop part. Now remember that these brackets, they can be positioned there, or you can bring them down here. Then this one can be positioned there, or you can bring them down there, okay? But in many cases, you'll find that they are positioned up here, okay? Yes, good. So the next item is, if you look at the setup, the void setup part, like I mentioned, whatever we put there will only be executed once, and every Arduino program must have the setup part, or you will always find that even if there's nothing that is put there, you must have the setup part as the first part of the Arduino program, usually coming immediately after we've declared the variables. Like if you you want to do pin declarations, you will do them before you join the void setup part, okay? So you can declare the pins, you can declare the variables at the very beginning of the program. And then from that section now, you advance to the void setup part. And within the void setup part, like I mentioned, whatever we put there will only be executed or will only be run once. And for example, we can put the pin mode functions there. and we can also specify the serial communication speed there. Okay. For example, if I wanted to set digital pin number 3 as output pin, the command I will use, I'll just say pin mode, then into brackets, digital pin number 3, comma, output. So in that case now, I've configured the digital output pin number 3 as the output pin. If I want to specify the serial communication speed, for example, I can say capital S, serial dot begin into brackets, I put 9,600. So in that case, I will have specified the speed of communication via the serial interface to be 9,600 bits per second, which is sometimes, or in many cases, is usually called the baud rate. This one is usually called the baud rate, okay? And the other speeds, which of course we will see in the later videos or later lectures, the different speeds which are available for use. So the loop function is the body of the program or the Arduino-based program, and that is always present in any given Arduino sketch. And we've said that this part of the code will, of course, be run over and over again. We usually use it to, or this part of the program is usually used for reading inputs, analog and digital. It is the part that is used in running the key algorithms or the key decisions or the key steps that the program needs to go through to solve the problem, and then now firing or triggering the outputs. So in a nutshell, this is like the section of the Arduino program where almost everything takes place, and a good percentage of work in the problem solving will be executed or performed under this section. So when we go to the Arduino IDE itself, this is how the two sections appear. If you look at the Arduino IDE itself, you will find like the this part here now is the part that is for the void setup part. So whatever we put there will be run once, and then this part here will be the void loop part. So every Arduino-based program will always have those two parts. Will always have those two parts or those two sections. If I can quickly refer to the Arduino IDE itself, then I can maybe show the appearance of this in the actual Arduino IDE environment, and perhaps also illustrate how we can access the built-in examples. So I'm starting my Arduino IDE. Starting my Arduino IDE. Yes, so here I've started my Arduino IDE. So if I start my Arduino IDE, let me come here to new sketch. So this one will give us a new coding window. And when you click that, you can see that now there are two sections which will appear. This one here is the void setup part, and then this one here is the void loop part. Remember that a program created using Arduino is what we usually call the sketch, and they are usually automatically given timestamps or dated. Like in this case now it is dated July 2020th, 2022. And this is labeled A because it is the first sketch window. And then if you open another one, it will be labeled B, C, and so on and so forth. Well, one of the main advantages of Arduino IDE is that it can allow you to open as many sketches or create as many sketches as you want, because each one will always be created in a new window. Each one will always be created in a new window. So for example, suppose we want to access a few examples, then you just come here, then you go to examples. So these are the built-in examples. So they are listed here from basics, digital, analog, communication, control, sensors, display, strings, USB, all the way down here. Then there are examples for any board, because there are different types of board, of course. Like now there are Adafruit circuit play, ground, the bridge, the explorer, the Ethernet, the formatter, the GSM, liquid crystal. And then when you come down here, you'll still get more. Okay, you'll still get more. Okay, I listed there. So for example, if I come up here to under basics, okay, and maybe you went to maybe check on maybe how you can maybe perform analog read of serial values or data, you can go there. Digital read serial, you can go there. Blinking LED, you can come here. The bare minimum we mentioned is here. Like suppose I go to blinking LED, then if I go to blinking LED, then you'll find now here, you presented with the sample code. Here you'll find that you are presented with the sample code on how to blink the LED. In future lectures, we will of course cover how we can write such programs, how we can write such programs. Like in this case, you can see clearly that the two sections we mentioned are applicable. The void setup part, for the void setup part, which is here, we only have one function there, which is a pin mode function, and it is specifying the inbuilt or the built-in LED pin to be used as output pin. And then under the void loop part, we have a digital write function, a high signal to the LED pin. Basically, that one we're using to turn on the LED. And then we are putting a delay of 1 second there. Then thereafter, we use a digital write, low signal to that pin. So that one will basically switch off the LED. And then again, we put a delay of 1 second and we're ending the program there. So you can see now there's this section, which is the void loop part. And then there is that section, which is the void setup part. And if the program doesn't have errors, usually when you come and verify here, or you can come to Sketch and then you click this one, verify or compile. If the code doesn't have errors, you will just be informed at the bottom here, where you will just see white messages, exactly, okay? So in this particular case, the code doesn't have errors. But if the code has errors, then those errors will be captured at the bottom here. So basically that is how the environment, the Arduino IDE environment looks like. And we have seen clearly that the Arduino IDE software or program has got two main parts. There is the void setup part, and there is the void loop part. In our next video, we will look at the basic functions, and we will begin by looking at the digital input-output functions. Thank you. Bye-bye for now. In case you're watching this channel for the very first time, kindly take time to subscribe. You can also like the video. Thank you for your continued support. Bye-bye for now.